Good morning, guys. Okay, so today we're going to look at the difference between surface area that we did previously. Then we're going to look at volume. And the last one we're going to look at is capacity. Right, so coming across over here, we spoke about surface area yesterday, is when we look at the area of every single face added up. So if I had to work out the area for each face of a 3D object and add them up, that's called the surface area. And we spoke about it being measured in units squared. So there I've got it in meters squared. And if it's a cube, so all the sides are the same, all the faces are the same, you could actually just go length times breadth for area and multiply that by 6 because they're all identical. But obviously, if it's like this one, this is a rectangular prism where not all the faces are the same, you would work out each one individually, length times breadth plus length times breadth plus length times breadth and so forth until you covered all the surfaces. Now, moving across to volume and capacity. So volume and capacity are worked out in the same way, but they have got different definitions. For example, the volume means how much space does that 3D object take up. So if I had to take a cube and put it in a bath of water, the water of the bath will come up a little bit because now there's a cube inside them that's taken up space and it's pushed the water up. So volume is how much space does it take, and capacity is how much can fit inside of it. So if I've got a jug of water or a container, the capacity means what is its capacity to hold something. How much can you fit inside of that object? Now, volume and capacity are much easier to work out than surface area. Surface area, you've got to think about every single face and add them up all together, and it can get quite complicated. But volume and capacity, you pretty much take the length and the breadth and you multiply it by the depth or the width. So all you're doing is multiplying 3 different dimensions by each other. So in this example here, I've got one of the dimensions is 2, the other dimension is 8, and the whole dimension going to the back is another 2 meters. So those are my 3 dimensions, 2, 8, and 2 again. So the formula for calculating volume and capacity is length times breadth times width, or length times height times width. It doesn't matter which way you name it, as long as you've got 3 different units being used or 3 different dimensions. So if I had to plug those into the length times breadth times width, 2 times 8 times 2. 2 times 8 times 2, and of course 2 times 8 is 16, and 16 times 2 is 32. Now, something to take note of is now we've gone to meters cubed, not like what we had before, meters squared. Now we've got meters cubed because we've got 3 dimensions. When we did area, we used meters squared because we only had 2 dimensions times each other, length times breadth. Now with volume, we've got 3 dimensions times each other, length, breadth, and width. So now it's meters cubed. And it's the same with volume, with capacity. But when it comes to capacity now, capacity is the way the units is different. It can be liters. You see over there, I've got 1 liter. It can be, what are the American ones that they use there? They've got ounces or pounds or whatever it is. They've got some other different unit, but we use liters and kiloliters and milliliters. So that tells you how much can fit inside of an object. There's Marcus saying hello. So when you're in the kitchen and you're using a 1 liter jug, that 1 liter tells you its capacity to hold something. It has the ability or capacity, Mike's, to hold 1 liter of a liquid. Now with volume, we're looking at how much space that thing takes. So volume will be the unit cubed, and capacity will be in liters, milliliters, or kiloliters. All right, so I'm going to give you some easy ones to try and work out the units of surface area, volume, and capacity. Right, all the best, guys.